video, I'm going to show you how you can use your graphing calculator to find a limit numerically. Now I have two examples here that we're going to use to illustrate this method. I have the limit as x approaches 0 from the right of the function 1 plus 1 over x, all raised to the negative x. And then using that same function, we're going to find the limit as x approaches negative 1 from the left. Now I pre-graphed this function, so we have an idea of what it looks like, and so then we can verify with our tables that we got the right answer. But looking at this graph, approaching 0 from the right, you can see that the limit is going to be 1 because that's the value of y that the function is approaching as x approaches 0 from the right. Now, if you notice, that value doesn't exist there because we have the open circle that indicates that there's no value there. But as you know, the limit can still exist even if the value doesn't exist. We need only be approaching that value. The function value does not have to actually exist at that point. Now, looking at the graph, you can see as we're coming from the left, approaching negative 1, the value of the function there does exist, and the value of the limit would be 0. As we get closer and closer to negative 1 coming from the left, we're approaching 0 for the y value. So now let's go ahead and look at how to do this numerically on the calculator using our tables. So the first thing we need to do is define our function. So I'm going to click on the y equals button. You want to make sure that all your stat blocks are off so that it doesn't interfere with anything that we're doing here. So to turn off all your stat blocks, you can just jump up using your arrow button and then click enter to turn it off if it's highlighted on. If it's on, it's going to look shaded like this. If it's off, it's going to be unshaded and it should look like this. So all my blocks are off so it doesn't interfere with what we're doing. Now, I'm going to put in my function. So in parentheses, I'm going to have 1 plus 1 over x, and I'm going to raise that to the power of negative x. Now, on my graph here, my y value is going from negative 2 to 2, and my x value is going from negative 3 to about 3.5. Let's do negative 3 to 3. So let's set up the window. So we're doing negative 3 to 3. And then on the y-axis, we're doing negative 2 to 2. Now we can just verify that the graph is the same. There's our graph. Notice that on our graphing calculator, the graphics on our calculator is not able to show the open and closed circles. So we need to be smarter than the calculator and know if it's open or closed at those endpoints. Okay, now to find these limits on the tables, we're going to first make sure that our table is set up correctly. So above your window button, it says table set. So I'm going to access that table set by hitting my second button and then window. We want to make sure that the independent variable says ask. And what that means is the calculator is going to ask the user what the x value is. And then we want the dependent variable to be on auto. So once the calculator asks the user what the x value is, the calculator will automatically tell you what the y value is. So we have it set up. So now we're going to go to the table by hitting second graph. And now we can start plugging in values. So if we're looking at this first limit and we want to approach 0 from the right, that means we want to plug in values that are close to 0 but bigger than 0. So let's say we plug in 0.1 and hit enter, then maybe 0.001. We want to get closer and closer to 0. And 0.0001, then 0.00001. Like we're just going to keep getting closer and closer. And you can see that the closer we get, we're going to get to 1. The calculator can only go out to so many digits, so it's going to round it to 1, when in actuality, it's probably like 0.9999999, a bunch of nines. but the calculator can only go out to so many decimal places, so then it rounds it to 1. So even though there is no value of the function there, it's going to round it to 1. And you can check that. If I plug in 0, it's going to give me an error message. So even though it says 1 here, you have to realize that this right here, 1 times 10 to the negative 6, the calculator is just rounding. There isn't actually a value at that point, at 1. Okay, so we can see using this table, as we get closer and closer to 0, we're getting closer and closer to 1. So we can say that this limit is 1. Even though the value of the function doesn't exist there, the limit does exist. We're going to go up and start over now. I want to now see what happens as I approach negative 1 from the left. So that means I'm going to be smaller than negative 1, but I'm going to get closer and closer to negative 1. So I'm going to have, for example, negative 1.2, negative 1.1. I'm going to get closer and closer to 1. Let's try negative 1.001. Let's try negative 1.00001. So we're going to keep getting closer and closer. You could see that this number over here is getting smaller and smaller and smaller. Let's see what happens if I put in a whole bunch of zeros. Negative 1.00000. Let's do a whole bunch and see if it gives me, there we go. So now we got so close to negative 1 that it gives me the value 0. So we can keep getting closer and closer, and we can use the table to find the limit numerically. So now I can put here that my limit is 0. Now if we were finding the two-sided limit, just the limit as x approaches 0, and not from a specific side, we would have to check values that are approaching 0 from either side, left and right. Now, if we do that for this function, we're going to get an error message because you see, as we approach 0 from the left, there are no values in the domain for this function between negative 1 and 0. So it's going to give us an error. But if we were using a different function and we were trying to find the limit coming from both sides, we would need to make sure we're checking values from both sides and to make sure that those values agree. So that's how you want to use your table feature on your calculator to help you determine limits numerically.